IWMF. The design of the Integrated Waste Management Facilities, IWMFs, is based upon best practices for safety, water management, and minimizing environmental disturbance. The two facilities beneath ZPV and Brskovo pits will accommodate all the mineral waste generated in the processes of mining and mineral processing. The steps of construction of the IWMFs are: the ground beneath the IWMF must be prepared, including the removal of trees, stockpiling of topsoil, the establishment of the under-drainage system and sealing of the ground using clay and geosynthetic lining systems to ensure that no leakage can occur into the groundwater. The mining waste will form the embankment before the wet tailings disposal area. This embankment will withstand the highest seismic event and ensure oxygen cannot reach reactive minerals within the mining waste. All outer surfaces of the embankment will be capped with a non-reactive impermeable layer. The IWMF is designed to ensure that water delivered with the flotation tailings will drain and that water is returned to the process water cycle. Permeable geotextile will be used to store the unsaturated flotation tailings and allow water to drain through and then away along highly permeable gravel pathways. Each cell is 10 meters high, and the construction process will start above the total tailings cell as it becomes fully solid and strong. As the mining waste rock embankment rises, it can be rehabilitated on lower levels, an outer level of clay and then topsoil. Native grass seeds will be sprayed onto the walls during spring and autumn. Once the grasses have stabilized, small and large trees can be planted on the berms. By the time the IWMF has reached its full capacity, some 75% of the facility will be rehabilitated, with only the upper walls and the top surface requiring capping, topsoiling and planting. Water management. There are surface water and groundwater considerations for water management. Groundwater will enter the project through the walls of the open pits and tunnels from old mining. All this water will be captured in ponds and used for mineral processing. No further use of groundwater is planned, and groundwater will be protected by using water sealing products under the IWMF and inside the water storage ponds. Surface water that can be diverted before it meets the project working areas will be channeled down to the lower Rudnitsa River. This includes a diversion channel of the Rudnitsa River itself, which must be diverted away from Brskovo pit and IWMF. Surface water that encounters project working areas will be captured in water storage ponds along with groundwater. This water will either be used to supplement mineral processing or treated to a high quality and released into the lower Rudnitsa River. Before ground and surface contact water can be released into the Rudnitsa River, it must be tested and treated. The treatment process has 2 stages as required. High-density lime powder is added to the water, which acts to precipitate all metals out of the water. This loaded lime is collected as a filtered sludge and deposited into the IWMF cells. Non-metals such as sulfates are treated using an ion exchange process. The loaded residue that is a byproduct of this process is similarly stored in the IWMF cells. About 75% to 85% of the water that is used for mineral processing is recycled, whilst 15 to 25% is stored in tailings, concentrates, or lost to evaporation. Processing water is recaptured from mineral processing by using a large thickener to separate most of the processing water from flotation tailings. The remaining process water will be collected through the IWMF water drainage process. The water treatment plant will also be used to maintain the necessary water quality for the mineral processing plant. Other uses for water stored in the water ponds is for dust control, particularly in mining, civil and IWMF activities in drier weather. Water for human consumption will be drawn from the Rudnitsa River and stored in a small pond. This water will be treated to become potable water. 2 biological wastewater treatment plants will be used to capture and treat potable water used in toilets, showers and washing. Closure of the mine. A plan describing how the mine will be closed and rehabilitated is a part of the current mine studies and is also required for permitting. The most significant impacts of the mine are the development of the 2 open pits and 2 IWMFs, the establishment of a mineral processing plant and of water storage ponds, and a water treatment plant. All these areas must be rehabilitated at the end of the mine life. The plan for mine closure is to close the open pits by replanting grasses and trees on the upper slopes that will sustain growth, form a small recreational lake at the base of ZPV where the groundwater level will re-establish itself and the natural rock will allow the lake to be formed in limestones. Progressively rehabilitate the IWMF surfaces by planting grasses and then shrubs and trees. The top surfaces of the IWMFs can be fully forested, grassed, or a combination of both. Remove the mineral processing plant, mining facilities and other buildings and rehabilitate these areas with grasses and trees. When the project is closed, the potential for low-quality water to be formed on the project site is low. When all long-term quality standards have been met, the water treatment plant will be decommissioned. Most of the ponds can be filled in, rehabilitated and returned to agricultural use. As a safeguard, a passive water treatment wetland using local limestone and wetland plants to neutralize and clean any water running across the site will be established. A determination of the land use will be made by the government and the local community towards the end of the project's life. There are other social uses for this land that the project area and its facilities could be used for. These include using the surfaces of the IWMF for other social uses such as sports fields and trails, using the flat areas of the IWMFs and other platforms to create a renewable power plant. A concept study has indicated that a 35 megawatt per hour plant is feasible. Using the buildings and platforms for alternative industrial or tourism uses, agricultural and aquacultural uses. The water storage ponds could be used to support municipality or regional water management infrastructure. Brskovo pit could be converted to a regional landfill.